Sometime in the near future, a 1,300-pound NASA satellite, about the size of a large piece of furniture, is set for an uncontrolled plunge back to Earth after spending years in space. This advanced piece of scientific hardware will eventually become space junk, tumbling out of orbit in a fiery cascade through our atmosphere. NASA and the US Space Force will be tracking its descent, and they assure us the risk to anyone on the ground is minimal. But what will really happen in its final, chaotic moments? That phrase, uncontrolled crash, sounds pretty terrifying, doesn't it? It conjures up images of destruction. But is this destined to be a dramatic, dangerous event, or something else entirely? And most importantly, will you ever actually be in danger? Today, we're breaking down what to expect. We'll explore what this satellite was, the incredible discoveries it made, why its journey is expected to end years earlier than planned, and the real risks of its return. We'll separate the science fiction from the scientific fact to find out what happens when our eyes in the sky finally fall. The Space Sentinel, what was Van Allen Probe A? So, what exactly is this satellite that's going to fall out of the sky? This isn't just a random piece of hardware, it's one half of a groundbreaking mission called the Van Allen probes. Originally named the Radiation Belt Storm probes, two identical spacecraft, Probe A and Probe B, were launched back on August 30, 2012. They were sent on a daring journey into one of the most hazardous regions of near-Earth space, the Van Allen radiation belts. To get why this mission was such a big deal, you need to understand the belts themselves. Imagine Earth wearing two huge, invisible, donut-shaped force fields. These are the Van Allen belts, vast rings of high-energy particles captured by our planet's magnetic field. They act as a vital shield, protecting us from cosmic radiation and solar particles. But this also makes them incredibly dangerous for technology. The intense radiation can fry electronics, so most satellites and all crewed missions try to get through them as fast as possible. The Van Allen probes were different. They were built like tanks, specifically hardened to not just survive in this harsh environment, but to live there. The mission, managed by the Johns Hopkins Applied Physics Laboratory, was planned for only 2 years, but the probes were so tough that they operated for nearly 7. During that time, they completely rewrote our understanding of space weather. Their data has led to over 700 scientific studies. One of their most stunning discoveries happened just days after launch. For decades, we thought there were only 2 radiation belts. The probes detected, for the very first time, a temporary third belt that can appear during intense solar activity and then vanish. This single discovery changed the textbooks. The probes helped us understand how the belts swell and shrink and react to solar storms, knowledge that is critical for protecting our GPS and communications satellites and for keeping astronauts safe. The long fall to Earth mission officially ended in 2019 when both probes ran out of fuel, making it impossible to keep them properly oriented. They were decommissioned and left to their fate. But if the mission ended back then, why is probe only coming down now? And why is its descent described as uncontrolled? When a satellite runs out of fuel, it begins a long, slow spiral known as orbital decay. Even hundreds of miles up, there are still traces of atmosphere that create drag, acting like a gentle brake that slowly pulls the satellite closer to Earth. When the mission ended, original estimates suggested this process would take about 15 years, placing Van Allen Probe A's re-entry sometime around 2034. But the Sun had other plans. Those calculations were based on a standard model of the Sun's activity. What wasn't predicted was that the current solar cycle 25, would be far more active than expected. This heightened solar activity heats up and expands Earth's upper atmosphere, making it puff out farther into space. For Probe A, this means the thin atmosphere it's flying through suddenly becomes much thicker. That gentle break of atmospheric drag is now a much stronger one. The effect is dramatic. Its orbital decay is accelerating significantly, pulling it down far faster than anticipated. This is what uncontrolled re-entry means, not that it's tumbling chaotically, but that there's no engine or fuel left to guide it. Its final path is being dictated purely by gravity and the unexpectedly powerful influence of our star. This complex dance between a satellite, our atmosphere, and the Sun is key to understanding the real dynamics of space. It's a reminder that even dead satellites are part of an active, changing environment. If you find this breakdown of orbital mechanics and space weather fascinating and want to support more deep dives into the science shaping our world, take a moment to hit that subscribe button. It's a simple click that helps us continue to explore these incredible stories for you. The fiery finale, the big question remains, what will actually happen during those final hours? And will we, down on the ground, ever be in any real danger? As probe dips below the 100-kilometer mark, the recognized boundary of space, its fate will be sealed. Traveling at hypersonic speeds, it will slam into the denser layers of the atmosphere. The forces involved are almost unimaginable. The friction will be so intense that the air in front of the probe will compress and heat up to thousands of degrees, creating a blazing fireball, a man-made meteor streaking across the sky. NASA expects that the vast majority of the 1,300-pound spacecraft will be completely incinerated. The lightweight aluminum structure and solar panels will vaporize in seconds. However, parts made from durable materials like titanium or stainless steel, things like fuel tanks or engine components, have a much higher melting point. It's these small, dense pieces that have a chance of surviving the re-entry and reaching the ground. This is precisely why organizations like the U.S. Space Force's 18th Space Defense Squadron have a global network to track these events. They won't just be watching a satellite fall, they will be monitoring a potential debris field, using radar to predict where any surviving fragments might land. Every step of its final journey will be watched. The real risk: were you in danger? So let's get to the heart of it. Will you be in any danger? The short answer is no. For events like this, NASA's casualty risk assessments are often around 1 in 10,000, a standard for ensuring public safety. While not zero, the odds of being struck by lightning are significantly higher. The risk from this satellite is, as NASA would state, low. There are a few reasons for this. First, over 70% of our planet is covered by water. Much of the remaining land is uninhabited. The probability that a small piece of falling debris will hit a populated area is already incredibly small. Second, based on its orbit, the most likely scenario is that Van Allen probe will re-enter the atmosphere over a remote stretch of ocean. Any components that survive would splash harmlessly into the sea, thousands of miles from any human settlement. The term uncontrolled crash creates a sense of unpredictable danger. But for the agencies that track these events, it's a highly predictable and monitored process. While they can't steer the satellite, their models can forecast its trajectory with increasing accuracy, allowing them to confirm that its path poses no threat to populated regions. The bigger picture: a crowded sky, the eventual, safe demise of Van Allen probe will close the book on a fantastically successful mission. But this one event is part of a much larger and growing problem: space junk. Probe A is just one of thousands of defunct satellites and spent rocket stages orbiting Earth. Beyond these are hundreds of thousands of smaller, untrackable pieces. Every new launch adds to the population, and as we're about to see, what goes up must eventually come down. Historically, we've had some close calls. The re-entry of the American Space Station Skylab in 1979 scattered debris across Western Australia. More recently, the uncontrolled re-entries of massive Chinese Long March rocket boosters have caused legitimate concern. The real danger isn't just the small risk of debris hitting the ground. The bigger threat is in orbit. Scientists worry about a scenario known as the Kessler syndrome, where the density of objects in orbit becomes so high that a single collision could set off a catastrophic chain reaction. Each collision would create a new cloud of debris, increasing the chance of more collisions, until entire orbits become unusable. This is a problem that space agencies are taking seriously. New technology is being developed to tackle it, from nets and harpoons designed to capture dead satellites to sails that can drag them out of orbit to burn up safely. The end of Probe A's journey is a stark reminder that we need a plan for managing our increasingly crowded skies. So, to sum up, the satellite's return isn't a crash so much as a predictable orbital decay, sped up by a surprisingly active sun. The Van Allen probe's mission was a monumental success that changed our understanding of the space around our planet. Its fiery end will be carefully tracked, and thanks to the simple odds of a water-covered planet, its final moments will almost certainly pose no danger to anyone as it disintegrates over an empty stretch of ocean. The real story here isn't one of danger, but of incredible scientific achievement, the powerful forces of nature, and a clear warning about the challenges we face in keeping our orbital environment safe for the future. Now we want to hear from you. What do you think is the best solution for the space debris problem? Should the responsibility fall on the nations and companies that launch these objects, or do we need a new international effort to clean up our skies? Let us know your thoughts in the comments below.